The Galactic Scientific Council prided itself on maintaining the most comprehensive database of habitable worlds in known space. Every planet, moon, and artificial habitat was meticulously categorized based on thousands of environmental factors. So when Chief Researcher ZYXTAL received the preliminary report from Monitoring Station Delta 447, she assumed there had been a catastrophic sensor malfunction. "Impossible," she muttered, her crystalline appendages clicking rapidly against her workstation. "Run the scans again." The AI responded with the same data: complex technological signatures detected on Helios 6, a volcanic moon that, by all known scientific principles, should be completely inhospitable to carbon-based life. Surface temperature, 480 degrees Celsius. Atmospheric pressure, 90 times standard. Constant electrical storms generated by interaction between volcanic gases and the magnetic field of the gas giant it orbited. Yet there they were: cities, roads, power signatures, and most impossibly of all, life signs. Thousands of them. "Prepare my ship," ZYXTAL ordered, her voice carrying the weight of scientific authority. "And alert the Council. We may have just discovered something that breaks everything we thought we knew about the limits of life itself." The journey to Helios 6 took 3 standard weeks. ZYXTAL spent every moment reviewing the data, searching for any explanation that wouldn't upend centuries of xenobiological science. Her research team, the finest minds in the Galactic Federation, proposed and discarded hundreds of theories. As they entered orbit around the volcanic moon, even the most skeptical member of her team fell silent. Through the ship's reinforced viewport, they could see them, dome-like structures scattered across the volcanic plains, connected by tubes that spiderwebbed between active lava flows. And moving between them, tiny figures in what appeared to be laughably thin environmental suits. "By the first stars," whispered Dr. Venare, the team's atmospheric specialist. "Those are humans." The word sent a ripple of disbelief through the bridge. Humans were a relatively new species to the galactic community, having achieved faster-than-light travel barely 2 centuries ago. They were considered a minor civilization, interesting primarily for their unusual social structures and surprisingly advanced entertainment technology. "Impossible," ZYXTAL said, but without conviction. "Their biology couldn't possibly." Her voice trailed off as they watched a group of humans casually repairing what appeared to be a geothermal tap, standing knee-deep in rock that should have been hot enough to vaporize their environmental suits instantly. "Opening communications," announced the ship's AI. "They're responding." The viewscreen flickered to life, showing a human female with dark skin and startlingly white hair. She wore what appeared to be standard industrial clothing, not the heavy protective gear that any sane species would require in such conditions. "Welcome to New Pompeii," the human said, smiling. "I'm Director Sarah Chen. We've been wondering when the galactic community would notice us. Would you like a tour?" The landing procedure alone demonstrated the absolute insanity of human engineering. Their shuttle had to be modified with additional heat shielding just to survive the descent, yet they could see human vehicles moving about with seemingly minimal protection. Inside the main dome, Director Chen met them in what she called the adaptation chamber, a series of airlocks that slowly adjusted pressure and temperature to comfortable levels for non-human visitors. "I apologize for the wait," Chen said as ZYXTAL's team finally emerged from their protective suits. "We don't get many visitors who need this level of environmental adjustment. Most of our trade is handled by automated ships." "How?" It was the only word ZYXTAL could manage. "How is any of this possible?" Chen's smile widened. "Would you believe it started as a mining accident? About 50 years ago, one of our deep-crust extraction ships crashed here. The crew should have died instantly. Instead, they survived long enough to realize something extraordinary: their emergency suits were functioning far beyond their design specifications. Something about human physiology, combined with our technological adaptability, allowed us to survive conditions that should have been instantly fatal. But the pressure alone. Dr. Venare interjected. Oh, that was tricky, Chen admitted. We lost the first few settlements to crustal shifts. But humans are remarkably good at learning from their mistakes. Now we build with the pressure, use it to our advantage. Those domes you saw. They're actually held together partially by the atmospheric pressure itself. The more it tries to crush us, the stronger they become. Zwickstall's scientific mind was racing. Your population readings, you're not just surviving here. You're thriving. Current population just passed 20,000, Chen confirmed. We're actually having to build new residential domes to keep up with demand. Turns out some humans really enjoy living in what most species would consider hell. The volcanic springs make for amazing hot tubs, once you figure out how to regulate the temperature. The tour continued through the settlement, each revelation more astounding than the last. Humans had not just survived in this impossible environment, they had turned it into a home. They grew food in specially designed hydroponic chambers, using the abundant geothermal energy to power their civilization. Children played in pressurized parks, their laughter echoing through corridors that should have been crushed to atoms. I need to know everything, Zwickstall declared as they watched a group of human engineers casually discussing repairs to a lava cooling system. Every adaptation, every technology, every biological change that makes this possible. Chen's expression turned serious. We'll share what we can, but honestly, a lot of it we did by trial and error. Humans have this peculiar ability to just figure things out when we need to. We call it winging it. Winging it, Zwickstall repeated, the translation making her crystalline structure vibrate with disbelief. You conquered one of the most hostile environments in the galaxy by winging it? Pretty much, Chen shrugged. Though we prefer to call it aggressive adaptation. As Zwickstall began composing her preliminary report to the council, she realized that no amount of scientific language could capture the true magnitude of what she was witnessing. Humanity hadn't just survived in hell, they had made themselves at home there, and they had done it with a casualness that defied comprehension. The implications were staggering. If humans could adapt to these conditions, what else were they capable of? What other, impossible, environments might they colonize? And more importantly, what did this mean for the future of galactic expansion? One thing was certain, the galaxy would never look at humans the same way again. The research team's second day in New Pompeii began with what the humans casually called a minor seismic event, a tremor that would have leveled most cities back on the galactic hub. Yet the human structures simply flexed and adapted, their innovative designs turning destructive force into sustainable energy. The hardest part wasn't surviving the environment, Engineering Chief Marcus Wong explained as he led Zwickstall through the colony's central power facility. It was learning to work with it instead of against it. Zwickstall watched in fascination as rivers of molten rock flowed through transparent conduits, their heat transformed into power through technology that somehow managed to be both incredibly sophisticated and deceptively simple. Your materials science alone defies conventional physics, she noted, her sensors struggling to analyze the transparent barriers containing literal rivers of lava. Wong laughed, the sound echoing off walls that hummed with contained energy. Conventional physics had to take a back seat to necessity. We call this stuff adaptive crystalline matrix, but honestly, it started as a manufacturing accident. Someone noticed that certain silicate compounds, when exposed to extreme pressure and heat, develop some interesting properties. Interesting properties, Dr. Venare repeated skeptically. You're containing plasma-hot material with what appears to be modified glass. The more heat it absorbs, the stronger it gets, Wong explained, tapping the barrier. Kind of like how human muscle gets stronger under stress. We just had to figure out how to replicate that principle in non-organic materials. The tour continued through what the humans called their agricultural sector, a series of massive chambers where plants grew in soil that should have been too toxic to support life. Dr. Maya Patel, the colony's chief botanist, greeted them with soil-stained hands and an enthusiastic smile. We learned pretty quickly that Earth plants weren't going to cut it here, she explained, showing them rows of vegetables that seemed to glow with an inner light. So we started experimenting with genetic modifications. Turns out extreme environments can produce some extraordinary adaptations. She plucked what appeared to be a tomato from a nearby vine. Under HFY's scanners, it revealed a cellular structure unlike anything in the galactic database. The plants had to learn to photosynthesize using the light from the lava flows, Patel continued. They developed these incredible heat sink properties. One of these tomatoes can provide enough calories to sustain a human for 2 days, and they're practically immune to radiation. But it wasn't just the technology that fascinated HFY, it was the culture that had evolved alongside it. In the community spaces, she observed humans gathering for what they called pressure cooking competitions, turning the extreme atmospheric conditions into a culinary art form. Children played games that incorporated the constant seismic activity, their laughter a counterpoint to the deep rumble of the moon's core. How do you maintain psychological stability in these conditions? She asked Dr. Sarah Chen during their evening meal. Most species would experience severe stress responses to constant environmental threats. Chen considered this while sipping from a cup of what she called volcanic brew, a beverage that actually required extreme pressure to properly prepare. We found that transparency helps. Everyone in the colony understands the risks, but they also understand the systems that keep us safe. Knowledge defeats fear, you know. A sudden tremor shook the dining hall. None of the humans even paused their conversations. Plus, Chen added with a smile, there's something about living in an environment that should kill you that really puts other problems in perspective. Our community mental health statistics are actually better than Earth's standard baseline. The most remarkable revelations came from the colony's medical bay. Dr. James Kumar, the chief medical officer, showed them scans of human residents who had lived in the colony for several generations. We're seeing actual genetic adaptations, he explained, pointing to cellular structures that seem to be evolving in real time. Increased bone density, enhanced heat tolerance, more efficient oxygen processing. The human body is literally rewriting itself to thrive here. That's not possible, HFY protested. Evolution doesn't work that quickly. Conventional evolution doesn't, Kumar agreed. But we're not conventional. Something about the human genome allows for rapid environmental adaptation when under extreme stress. We call it crisis evolution, though some of my colleagues prefer the term stubborn genetics. As the day drew to a close, HFY found herself in one of the observation domes, watching the spectacular light show created by electrical storms in the toxic atmosphere. Beside her, a human child was doing homework, occasionally glancing up to use the lightning flashes as inspiration for what appeared to be an art project. Doesn't it scare you? HFY couldn't help asking. Living here? The child looked up, genuinely puzzled. Why would it? This is home. That simple statement perhaps summed up humanity's greatest strength. They didn't just survive in impossible conditions, they found ways to make those conditions normal, comfortable, even beautiful. Where other species saw certain death, humans saw opportunity, challenge, and eventually, home. As HFY prepared her daily research notes, she added a personal observation. Perhaps the most remarkable adaptation isn't in their technology or their biology, but in their perspective. Humans don't overcome impossible conditions, they simply refuse to accept that anything is truly impossible. The implications of this revelation would soon prove to be far more significant than anyone could have anticipated. The Galactic Council's emergency session was held in a chamber specifically pressure-adjusted to accommodate both the research team and a delegation from New Pompeii. HFY couldn't help but notice how uncomfortable her fellow council members looked, while the humans seemed perfectly at ease despite the non-standard atmospheric conditions. What you're suggesting is beyond radical, Council Elder Vurek stated, their luminescent form flickering with agitation. Joint research projects with a pre-Federation species? And in conditions that violate every safety protocol we've established? With respect, Elder, Dr. Chen interrupted, we've been violating your safety protocols successfully for 50 years now. Maybe it's time to reconsider what safe really means. The resulting collaboration would reshape galactic science forever. The first joint research facility was established on the outskirts of New Pompeii, combining human intuition with alien analytical precision. The results were immediately extraordinary. Dr. Kumar worked with alien biochemists to decode the mysteries of human cellular adaptation. It's not just our bodies adapting, he explained during one particularly intense session. Our very DNA seems to have a built-in flexibility that we never knew existed. When faced with conditions that should kill us, our cells don't just resist, they restructure. In the engineering labs, Marcus Wong's team partnered with alien materials scientists to develop new applications for their adaptive crystalline matrix. Turns out, he announced one day, barely containing his excitement, the same principles that let us contain lava can be applied to starship hulls. We're looking at vessels that could survive direct contact with a star's corona. But it was in the agricultural sector that the most surprising breakthroughs occurred. Dr. Patel's modified plants weren't just surviving, they were thriving in ways that defied conventional biology. The symbiosis is extraordinary, alien botanist Recta marveled, examining a flowering plant that produced both edible fruit and industrial-grade lubricant. These plants aren't just adapting to survive, they're actively exploiting conditions we thought were lethal to create entirely new biological processes. Necessity is the mother of invention, Patel responded with a shrug. When your only options are adapt or die, you get creative. The implications extended far beyond New Pompeii. If humans could adapt to these conditions, what other, uninhabitable, worlds might they colonize? The possibility both excited and alarmed the Galactic Council. Your species represents a variable we never considered, Council scientist Youthlar admitted during a private meeting with Chen. The ability to not just survive but thrive in conditions that would kill most species, it changes everything we thought we knew about colonization potential. But not everyone was thrilled with these developments. During a routine conference call with the Council, ZYXTAL noticed several members expressing concern about the pace of human advancement. They're moving too fast, one Council member warned. A species that can adapt to any environment, the strategic implications. Chen, overhearing this, stepped forward. We understand your concerns, she said, her voice carrying that peculiar human mix of diplomacy and determination. But consider this, every adaptation we develop, every breakthrough we achieve, we're willing to share. We're not looking to conquer the galaxy. We're looking to expand the definition of what's possible. The turning point came during an unexpected crisis. A series of particularly violent seismic events threatened to destabilize the very crust of Helios 6. While the alien researchers prepared to evacuate, they watched in astonishment as the humans not only stayed but developed and implemented solutions in real time. The pressure waves are actually helping us, Wong explained as he coordinated emergency teams. We're using the seismic energy to reinforce our structural fields. The worse it gets, the stronger we become. That's not scientifically possible, an alien physicist protested. Tell that to the buildings that aren't collapsing, Wong replied with a grin. Sometimes the best science happens when you stop telling the universe what it can't do and start asking what it might do if you give it a chance. As the crisis passed, ZYXTAL found herself updating her research conclusions yet again. The humans weren't just adapting to impossible conditions, they were teaching the rest of the galaxy to rethink the very concept of impossibility. Perhaps, she wrote in her personal log, the most valuable adaptation humans bring to the galaxy isn't their physical resilience or their technical innovation. It's their ability to look at what every other species calls impossible and ask, are you sure about that? The true test of this philosophy, and humanity's place in the galactic community, was about to face its greatest challenge yet. The warning came 3 days before disaster struck. The gas giant that Helios 6 orbited was entering an unprecedented period of gravitational instability, threatening to tear its volcanic moon apart. Even the humans' sophisticated adaptation systems weren't designed to handle this level of planetary stress. Complete evacuation is recommended, the Galactic Council declared. The structural integrity of the entire moon will be compromised within 72 hours. Director Chen called an emergency meeting in New Pompey's Central Command Center. Zyxtal and her research team watched as humans calmly discussed what most species would consider an extinction-level event. Evacuation isn't an option, Chen stated firmly, studying the holographic models of the approaching catastrophe. We have over 20,000 residents, plus critical infrastructure that took generations to build. Not to mention the experimental crops that could revolutionize food production across the galaxy. The alternative is death, Council Representative Vurex argued via holographic link. Even your remarkable adaptability has limits. Wang, who had been quietly running calculations, suddenly straightened. Maybe not. What if we could use the gravitational stress to our advantage? The next 60 hours demonstrated why humans had survived where others would have perished. Instead of running from the disaster, they began actively preparing to harness it. The basic principle is simple, Wang explained as teams rushed to modify the colony's structural systems. We already use volcanic energy to power our civilization. The approaching gravitational surge is just another form of energy. If we can't stop it, we'll ride it. Zyxtal watched in amazement as humans transformed their entire colony into what they called a gravitational surfboard. Heavy industry was converted into resonance dampeners. The adaptive crystalline matrix that contained their lava flows was reprogrammed to channel gravitational waves. This is insanity, Dr. Venare muttered as they observed humans installing new equipment in environmental suits that should have failed under the increasing stress. The energy involved could tear apart atomic bonds. Probably, agreed a passing human engineer, adjusting what appeared to be a makeshift gravitational wave detector. That's why we're adding quantum stabilizers to the mix. Anyone know any good surfing prayers? The situation grew more dire as the deadline approached. The moon's crust began to fracture in new and unpredictable ways. Toxic gases vented from fissures that hadn't existed hours before. The alien research vessel, despite its advanced technology, was forced to retreat to a safer orbit. But the humans stayed. Not just stayed, they adapted in real time. We're seeing some interesting readings from the new fissures, Dr. Patel reported during one of the hourly status updates. The gases are similar to what we use in our agricultural domes. If we can redirect them. Do it, Chen authorized. Every crisis is an opportunity. When the gravitational surge hit, it exceeded even the worst predictions. The moon's surface rippled like water. Lava geysers erupted kilometers into the space. The atmospheric pressure fluctuated wildly. And New Pompeii rode the wave. Wang's modifications worked better than anyone could have predicted. The colony's structures flexed and flowed with the gravitational tides instead of fighting them. The new gas vents were successfully integrated into the agricultural systems, actually improving crop yields despite the chaos. Most remarkably, the humans turned the entire experience into what they called a learning opportunity. The data we're collecting is unprecedented, Kumar reported excitedly as the colony surfed another gravitational wave. The way our bodies are adapting to these conditions, we're seeing cellular evolution in real time. You're studying your own biological responses during a planetary catastrophe? Zyxtal asked incredulously. Well, yeah, Kumar grinned. When else are we going to get conditions like these? Besides, the kids are treating it like an amusement park ride. We've had to institute a sign-up system for the observation domes. The crisis lasted for 5 days. When it finally passed, New Pompeii hadn't just survived, it had emerged stronger. The new adaptations and technologies developed during the emergency had made the colony more resilient than ever. I don't understand, Council Elder Vurex admitted during the post-crisis assessment. By all our models, this moon should be a debris field right now. That's because your models assume survival means avoiding disaster, Chen explained. We've learned that sometimes the best way to survive is to embrace the chaos and make it work for you. ZYX Tao, reviewing the data from the event, realized she was documenting more than just an extraordinary feat of survival. She was witnessing the emergence of a new paradigm in galactic civilization. Humans don't just adapt to survive, she wrote in her report. They adapt to thrive. And in doing so, they force us to question everything we thought we knew about the limits of possibility. The galaxy would never be the same. 1 year after the gravitational crisis, New Pompeii hosted the first Galactic Adaptation Summit. Representatives from hundreds of species gathered in specially designed environmental chambers to discuss what many were now calling the human factor in galactic evolution. ZYX Tao, now heading the newly formed Department of Human Studies, watched with pride as Director Chen delivered the opening address. A year ago, many of you considered our survival impossible, Chen began, standing confidently before the diverse audience. Today, we're not just surviving, we're teaching other species how to thrive in conditions they once feared. The question is no longer whether something is possible, but how we can make it possible together. The evidence was undeniable. The adaptive technologies developed on Helios 6 had already revolutionized colonization efforts across the galaxy. Species that had been confined to narrow environmental bands were exploring new worlds using modified versions of human environmental systems. The most remarkable aspect, Dr. Kumar presented during the medical symposium, isn't just our physical adaptability. It's how this trait has influenced our entire approach to existence. Humans don't accept limits, we see them as challenges to overcome. The summit's exhibits showcased achievements that would have been dismissed as fantasy just a few years earlier. The adaptive crystalline matrix, now refined through collaboration with alien scientists, was being used to construct ships capable of diving into gas giants. Modified versions of Dr. Patel's pressure-resistant crops were growing on worlds once thought permanently barren. But it was the cultural impact that truly fascinated ZYX Tao. Species that had been historical enemies found common ground in their amazement at human adaptability. Traditional power structures within the Galactic Council were shifting as the definition of habitable space underwent radical revision. You've changed everything, Council Elder Vurex admitted privately to Chen. Our entire understanding of species classification, evolutionary potential, even the basic principles of colonization, nothing is the same. Change is the only constant, Chen replied with a characteristic human smile. We're just better at embracing it than most. The summit's most significant moment came during a demonstration of the new, Crisis Evolution, training program. Young aliens worked alongside human instructors, learning not just to survive in extreme conditions, but to see opportunities in adversity. The key isn't to fight the environment, a human instructor explained to a group of crystalline beings similar to ZYX Tao's species. It's to understand it, work with it, become part of it. Every condition has its advantages if you're willing to find them. The results were astonishing. Species that had evolved in strictly controlled environments were learning to adapt in ways their biology supposedly prevented. It wasn't just human technology they were adopting, it was the human perspective. During the summit's final session, ZYX Tao presented her comprehensive theory of human adaptive potential. What we're witnessing isn't just biological evolution, she explained. It's the emergence of a new type of species, one that treats environmental barriers as stepping stones rather than walls. The implications extended far beyond mere survival. Human adaptability was reshaping galactic society itself. Trade routes were being redrawn to include previously impossible regions. Diplomatic relations were evolving as species learned to see differences as opportunities rather than obstacles. Perhaps the most valuable lesson humans have taught us, ZYX Tao concluded, is that adaptation isn't just about surviving adverse conditions. It's about maintaining hope, curiosity, and determination in the face of the impossible. As the summit drew to a close, a young alien asked Chen what she thought the future held for human-alien relations. "Look around you," Chen replied, gesturing to the diverse gathering. "A year ago, half the species in this room couldn't survive within 1,000 kilometers of each other. Now they're sharing meals and trading jokes. That's the real power of adaptation, not just surviving together, but growing together." The legacy of New Pompeii extended far beyond its technological achievements. It became a symbol of possibility, a reminder that the boundaries of the possible were defined not by environmental conditions or biological limitations, but by the willingness to adapt, to innovate, and to reimagine what was possible. Zwickstow's final entry in her research logs captured the essence of humanity's gift to the galaxy. "In teaching us to adapt, humans have taught us something far more valuable: they've taught us to dream. And in a universe of infinite possibilities, that may be the most powerful adaptation of all." As New Pompeii continued to grow and evolve, its example sparked a renaissance of exploration and innovation across the galaxy. The human capacity for adaptation had done more than ensure their survival, it had shown the galaxy a new way to thrive. And somewhere, on a volcanic moon that should have been uninhabitable, children played in gardens that shouldn't exist, dreaming of what other impossible things they might make possible tomorrow.